All right. Let me just give a quick overview about what this lab is about. Okay. Um, if you go to these videos, the conservation of angular momentum videos, way, 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 way down here, okay, and you actually look at that on YouTube.
So this is the cool thing about
Blah, blah, blah. If you look at the comments here, you can notice that there's quite a few comments here. And that is because somebody on the internet has proposed an alternate model for conservation of angular momentum. And in his model, it's not angular momentum that's conserved, it's the kinetic energy that's conserved. Now, let me just talk about the specific experiment that he's talking about. Okay, so let's take a look at this. In this thing, I'm twirling this stopper around my head. Okay, now in the beginning of the video, you'll notice that the stopper is going around in a big wide circle. And then what I do is I pull my hand down and I pull it into a much smaller circle. So just watch this.
Yeah.
Could be any range between my
And pull it down.
You're like widely.
Now, there's two explanations for what's going on there. Okay, our first explanation, and this is Sir Isaac Newton, okay, is angular momentum is conserved. Now this will take a little explaining, but it's not too hard, right? Angular momentum, as you recall, is just I omega, right? And for a mass on the end of a string, that distance r, our moment of inertia is mr squared, okay? So what this becomes is basically I1 omega 1 equals I2 omega 2, right? And if we substitute, if we go m times r1 squared, right? And then we substitute in for omega, omega is just v over r, right? Because now we want to just see what the velocity is doing here, right? And then we have m r2 squared, right? And this is r1 there, right? Times v over r2 squared, not squared, sorry, okay? What happens here is that one of these r's cancels out. The mass cancels because we don't change the mass, right? And we end up with r1 v1 equals r2 v2. Okay, no Star Wars jokes there, right? So what this means is, let's say we start with, say, 100 centimeters, right? And it's going 1 meter per second. If we pull it into a distance of, say, 50 centimeters, well, you'd have to, the velocity here would have to be 2 meters per second, okay? So what this model states is that as you pull it in, the velocity increases. If you cut that distance in half, you double the velocity. If you cut it into 1/10, right? If you pull it to 10 centimeters, right, then it would go 10 meters per second, right? And what John Mandlbaur is objecting to is the notion that, say, you pull it into 1 centimeter, right? If you pull it into 1 centimeter, that means it's got to be going 100 meters per second, right? So he doesn't think that happens. But what he proposes is that the kinetic energy is conserved, right? That 1/2 m v1 squared is equal to 1/2 m v2 squared. Well, half is the same on both sides. M is the same on both sides. Square root both sides, v1 equals v2. Okay, so what he says is that the velocity stays constant, but because it's got a smaller distance to travel, it just looks like it's going faster, but the velocity stays constant. Now, so we have one model that is the constant velocity model, and one model that is the conservation of angular momentum model. In other words, the velocity increases, right? What you're going to have to do is come up with an experiment to show whether the velocity stays constant or not. Now, it's not enough to just show that the velocity is different. It could be different because of a mistake you made, right? Or it could be different because of inherent experimental error. We want to show that it's different by more than a calculated uncertainty. So you're going to have to calculate the velocity plus or minus that velocity, right? And the final velocity plus or minus that. Now, you might get that the velocity increases, but does it increase more than your uncertainty? So this is a bit like the momentum lab, only we're trying to look to see if it's actually different. Okay. So anyway, let's go back to the website here. Okay. There's a number of things you can do on this website. You could analyze that video that I made. So you could just use one of my videos here. Okay, you could use this as kind of an interesting video. Let's take a look at this guy. And this is an experiment I did. So let's just. Oh, that's loud. I let it spin around. It's going some majestic speed. And then I pull it from 20 centimeters to 12. That's what's going on here. Okay, so you could analyze this video, and this is what I did in response to the Mandlbaur hypothesis. Okay, so you could use my video, you could use this video there, right? You can also just use a video that you make. Okay, now if you use a video that you make, and you could even do this on your Chromebook using the video analysis app. Okay, you can, if you have a legacy, if you can record in a legacy like a really old codec, you can use Logger Pro on my computers. I can't tell you which one's better. It just depends on whether you want to use a PC or you want to use your Chromebook. Okay. Anyway, I'm just going to stop talking.